before we go over that, let's just look at what the homework is. Once we finish learning how to do all the stuff in Google Sheets, which we started the other day, do you remember we made 4 graphs the other day in Google Sheets? Okay, there are some additional things we're going to learn how to do with those to understand the patterns on the graphs. Google Sheets gives us some additional information. So we'll finish that up, and then you're going to use the lesson we learned about how to make a graph in a Google Sheet and this lesson that we're going to do about how to interpret those graphs in a Google Sheet to do a lab. And that's in a Google Sheet, surprisingly. Not surprisingly. Okay, it's a Google Sheet lab. That lab will be due tomorrow. So I'm just going to show you how to get started with it. You'll have the rest of the time to work on that today. And then you need to submit it and turn it in before tomorrow's class begins. For Tuesday next week, however, there is a review assignment to get you ready for your first unit exam, which is Wednesday next week. It is the rest of the packet, which is pages 21 to 24. All right, so you're going to want to work a little bit every day on those review questions to get you ready for that test. You don't get extended time on the test unless you're entitled to it because you have a written accommodation for that. Otherwise, you get the 40 minutes to complete it. If you're not completing it in the time that you're given, that means you don't know what you're doing. You didn't study well enough to get yourself ready. Okay, so that's just letting you know you're going to have to start to prep for that to get you ready for that test. Okay, so let's look at the rest of page 17. We did not get to how do we write the equation specific to this graph. In our notes yesterday, we talked about what the equation of a line is. And we're going to start with that equation of a line. What's that equation? Okay, y equals mx plus b. That's a general equation for a line. That does not tell me that this is the graph I have. That's why we're going to change every letter to the other things that are on this graph to make it specific. So the first thing I told you to do was change out the letter y to the name of the variable that's on the y-axis. What's on the y-axis? What's our dependent variable in this experiment? Position. So we're going to change the letter y to the word position. Do we know what the slope of this particular line is? Yeah, we just calculated it in part E. Positive 300 m over s in parentheses, because we're grouping those things together. Now you ask yourself, what is our independent variable? What was on the x-axis of this graph? Name it. Time. So we're going to write the word time. And then we have to add the y-intercept, which we get by looking at our graph, analyzing the graph at a value of 0 for the x-coordinate. And what is that y-coordinate right there? What's the y-coordinate? 100 what? Meters. Okay, so that is our y-intercept. That is the equation for this graph on page 17. It tells me what two variables were plotted on the graph. It's a position time graph that starts on the y-axis at a value of 100 meters, and it goes up 300 meters every second that it goes over. So it tells me exactly how to plot that line that's there. Any questions on that? Okay, you want to take a minute and edit the equation you wrote on page 18? Take a minute and edit the equation you wrote on page 18 for graph 2, now that I did that one with you. Mm-hmm.
Back to page 17.
Yeah.
When you did the slope formula,
Yep.
it was like the slope formula, like the answer should have been negative 260.
On page 17?
No, for like 14. Negative 1300 divided by 5. Shouldn't that be like
On page 17?
page 17? Yeah, sorry.
Okay, no, it's not. This graph is going up. You always do these values minus these values. You subtracted in the wrong order if you got a negative. It's the second y coordinate minus the first y coordinate. The second y coordinate was 1,400 meters minus 100 meters. That gives you a positive answer. There's no way you would get a negative on this. If it were a negative slope, the line would not go up. It would come down like that. Okay. All right. Let's look at page 18 then to make sure you have this correct. Number 2A, the independent variable is time because it's on our x-axis. The dependent variable on the y-axis is position. The shape of this graph, you should have said diagonal line. The relationship on this graph, you should have said indirect. Now to calculate the slope, again, it said show all work. So if you're missing any of the steps, you would not get credit for this on a test. It's either all right or it's all wrong. You need to show all the steps, and I am particular about what you show because that is how our Regents exam is graded. I'm prepping you already for June. So I told you to circle 2 points on the graph that I'm going to use in the slope calculation. I told you to use points that are far, far, far apart. I'm going to pick this point and this point. You're then going to use your guess method, listing the coordinates of the 2 points that you just circled in slope intercept form with their units. So my first point is at 0 seconds, 1,400 meters. The second point is at 5 seconds, 100 meters. My unknown is the slope. We write the same equation we wrote on our reference table yesterday. That slope is y2 minus y1 over x2 minus x1. We then do our substitution with units. That means it would be 100 meters minus 1,400 meters all over 5 seconds minus 0 seconds. Should be in this order. I should see all those things. If you left off one of these M's, the whole thing is wrong. You missed a unit. You got to have units after every number. Then remember, we do our subtraction. So that gives me negative 1,300 meters over 5 seconds. So when I solve this to get an answer with units and sig figs, here I get the negative value, right? There's the negative sign. Now I have a negative answer. And with one sig fig, again, because of the 5 seconds, this one was negative 300 m over s. So when we go to write our equation specific to this graph, again, we're going to have that position is equal to negative 300 m over s times time plus 1,400 meters for our answer. Okay. Any questions on page 18? Yep. Right. Yep. One sig fig because of the 5 seconds. Well, remember, you see why I did the subtraction first is because when we subtract, we keep track of the number of decimal places, the precision. So that's why I'm not rounding the top to negative 1,000 meters. I have to keep the precision. Both of these numbers are precise to the hundreds place, which means that numerator's got to go to the hundreds place, and it does. So the top has 2 sig figs, the bottom is 1, so I need 1 here. Make sense, everyone?
Page 17 was 260, right?
But with 1 sig fig, you got to round it up. Okay? Yeah, because it's the same thing. You got 2 significant digits in the numerator, 1 in the denominator. You got to round to 1 sig fig because of the rule for division. Okay? Any other questions on those 2 pages? The next page, I think, was super easy. Hopefully you thought so too. 3A, our independent variable is time. The dependent variable was distance. The shape of this, you should have said this was a parabola. And the relationship, you should have said quadratic. In number 4, part A, the independent variable is time. The dependent variable is distance. The shape, you should have said, was a hyperbola. Hopefully you spelled it correctly. And the relationship on this graph is inverse. Any questions? No? Okay. So here's what you're going to do. You can use this homework on today's quiz. You can always use your homework on the quiz, especially for scrap paper. You do need a calculator. You need something to write with. You can have out your reference table, since that's where we wrote the slope formula. But today's quiz is back on your Chromebook, so go ahead and grab your Chromebook. And the quiz for Unit 1H should be there. It's 3 multiple choice questions about interpreting graphs. Let's see if it posted that. Yep, it's there. Go ahead and take your quiz then for Unit 1H. We are going to use your Chromebook for the rest of the class, so please keep it out. Just when you finish the quiz, just collapse your screen a little bit so that way I can tell that you're done with the quiz and we can go on. Everybody done? All right. Could you please open up the Graphs in Google Sheets assignment that was pushed out to you a couple days ago? That's the one we started working on. I believe it's still in your to-do list here, the Graphs in Google Sheets assignment. You can go ahead and open that up. And when you open it up, remember this is what it's going to look like here. We made these graphs the other day. If you recall, there were 4 of them that we made, and we checked them in class to make sure everybody had the same thing. Got it open in front of you? I'm not going through this for me. I learned this in 1988. I think I'm pretty good with it. Okay, everybody has it? Okay, here's what we have to do with each of these. Do you see on the left side of the sheet over here that starting in B12, we're looking at the practice problem, starting in cell B12, that we have to answer some questions for this graph. It asks you for the shape, the relationship, the slope of the graph, the y-intercept, and the equation for that. So here's what we're going to do. Before we answer any of those questions, we are going to add one thing to our graph, which will help us answer all of those questions. You are not going to calculate a darn thing. You do not need a calculator. In fact, I want you to put your calculator away to make sure you are not calculating anything. Okay? Google Sheets gives you almost all of these answers automatically. So if you're starting to calculate something, you're doing it the wrong way. Here's what I'd like you all to do. Please double click on the graph. And when you double click on the graph, you get the chart editor window on the right. Yes? Okay. I am going to make my screen a little smaller so that way I can see more of what I'm looking at here. That's a little too small. There we go. That's better. Now, I would like you to go to the Customize option under Chart Editor. Double click on your graph. And once you've double clicked on the graph, you get this Chart Editor window that opens up on the right. Please click on the Customize option. And then I want you to scroll down to the Series submenu and expand it. Everyone done that? Okay. Now scroll down again with me. Do you remember where we selected our trend line? There's a check for that. And then we selected the type. We're not changing that. That stays all the same. We are going to add one more thing. You see there is an option for a label. Please select the down arrow. And it gives you three options: none, custom, or use equation. I would like you to click on use equation. And you'll see that as soon as you do that, it gives you an equation. It's not the full equation, but it is an expression. Oh, the thing decided to reboot. Give it a second to reconnect. Sorry about that. Bluetooth obviously just disconnected. It's rebooting. There we go. Technology is wonderful when it works. There we go. Okay. So this is an algebraic expression for the equation for this, which we're going to need in a minute, but we have to modify some things on this. All right, now we can start typing in cell B12 our answers for this graph. So based upon what we learned yesterday, can you tell me what shape that graph is? Who can tell me? Okay. That's right. Go ahead, type that in. That is a diagonal line. Make this a little bigger. Okay. Now let's move down to cell B13. What relationship is shown on this graph? Chaudhry? Correct. Let's go ahead and type in direct in cell B13. Okay. The slope was given to you in the Google Sheet. And it is in this equation that's here. If you remember the equation of a line, what's the equation of a line? All lines? Y equals mx plus b. That is missing the y on the left side of the equal sign. But it gives you the x and it gives you the b, and it's also giving you the m. The m is your slope. It's the value in front of the x letter. What's the value that it gave you? 1.5. Now we have to add units to it. If we think about calculating the slope of that graph, remember that what we do is we get units of the y-axis over units of the x-axis. So that means our slope here would have units of cm over n. And you have to tell me whether this is a positive slope or a negative slope, because that positive or negative is going to mean something once we start learning the physics. Is that slope positive or negative? Okay, so let me show you how you have to type this in. It's really weird how Google Sheets makes us type it when we put a sign in front. You have to start with a parenthesis. Otherwise, it's going to assume that you're doing a formula. It wants you to evaluate a formula. We don't want it to do that. So we're going to start with our left parenthesis, put your positive sign, then type the value, which was 1.5. Then we'll put our space, and then we'll put our units, which are cm divided by capital N. And it does need to be a capital N. A lowercase n means something else in physics. We type them exactly as they are. Okay, any questions about that? Yep. I'm sorry? Yep. Is that better? You see it? Positive 1.5 cm divided by n, but you got to put that all in parentheses. Otherwise, the Google Sheet's going to give you an error. Okay, everybody all set? Okay, now again, we are not going to figure out ourselves what the y-intercept is. The Google Sheet gave it to you in that equation. Where is the y-intercept in that general equation? What letter? It's the B. Look at the equation that was given to you on the graph. The B is after the plus sign. Do you see it? What's the value? 0. Now, what are the units of the y-intercept of this graph? cm. That's right. So what we're going to do, I should not see any calculators out. Put your calculator away. Put it away. You don't need it this whole double period. Thank you. The y-intercept is 0 cm. Follow it with the unit, please. You're not calculating anything. It did it all for you. You don't even have to know what the slope formula is to do this. Now we're going to write the equation. It gave us the partial equation. We have to modify it so it looks like what we need. So remember how we start the equation. We start with the variable that's on the y-axis. What word is on the y-axis? All right, so let's start typing elongation equals, then we're going to put in our slope value with the parentheses, positive 1.5 cm divided by capital N times the x variable. What's on the x variable of your graph? Force. So let's put the word force. You don't have to put a time sign. You can just put the word force right after the parenthesis, plus your y-intercept, which was 0 cm. Enter. And then it just saved it for you. Okay. Is everybody okay with that? Okay. Let's now go to problem 1 then. We're going to do the same thing with problem 1. So the first thing I need you to do, double click on your graph. What do I need to add to this graph now? The equation. You remember where that is? Under what submenu? Series. Let's go down to series. You're going to look for the label and change the label from none to use equation. And then you can get out of the graph. Okay. Let's now talk about the shape. What is the shape of this graph? What is it, Alex? You have it? It is a hyperbola. Very good. Hyperbola. Hyperbola. What is the relationship on this graph? Sydney? Very good. It is inverse. Okay. Now, would this graph have a slope? When do we have slopes? What type of graph gives you a slope? A line. Is that a line? So are we going to have a slope? So put NA, meaning not applicable. There is no slope to worry about. Is there a y-intercept to worry about? No, because it's not a line. So what are you going to put for the y-intercept? NA. Is there an equation to write? No, because it's not a line. NA. See how easy that was? When it's a curve, there's a lot less for you to do. Let's go to problem 2. Start by adding the equation to this graph, please. Double click on your graph, go to the Customize option, expand the Series submenu, and change the label from None to Use Equation. Okay, let's start typing in cell B12. What shape is this graph? Parabola. What is the relationship on this graph? Yes, it is quadratic. Is there a slope to worry about? No, so NA. Is there a y-intercept to worry about? No, NA. Is there an equation to write? No, NA. Done. Can we move on to problem 3? All right, let's look at problem 3. Double click on your graph, add the equation. Wrong spot. Okay. What is the shape of this graph? Very good. Diagonal line. What's the relationship on this graph? Emma, can you tell me? Yes, it is direct. Okay, let's talk about the slope. I'm going to put it in parentheses. Anybody tell me what the slope of this graph would be? Right? Okay, that is the value. Is it positive or negative? So make sure you put the positive sign. Now we have to get the units. What units are we going to put on this slope? 20.9, what? M/S /S, because it's the units of the y-axis over the units of the x-axis. The y-axis is an M/S. The x-axis is an S. So we're going to do M/S/S. I'm sorry? Because nothing is being multiplied. These are not multiplied. And when you do slopes, you're dividing one thing by the other, not multiplying. Okay. All right. What's the y-intercept of this graph according to the equation that Google Sheets gave you? Who can tell me the y-intercept? One? No, not according to the equation. You have to use the Google Sheet equation to give you the y-intercept. Ryder, can you help me with that? Very good. 0.0476. It's this value after the plus sign in the equation. And then the units of the y-intercept come from the units of the y-axis label. It is a y-coordinate, which is labeled meters per second. All right, now we have to write the equation for this. So we're going to use that y equals mx plus b to modify it for this graph. So what are we going to put for the y? What word? Haley, can you tell me? Good. So we're going to start with speed. Whoops. Equals. Then we put in the parentheses the slope, positive 20.9 M/S/S. What are we going to put for the x? Ryder, can you tell me? Time. Good. Plus. And then what am I plugging in for the y-intercept? Just what I have right above it. 0.0476 M/S. Okay, now my graph is covering up my equation. So I'm going to move my graph over a little bit more so I can see the full equation on the screen. If yours covers up anything that you just typed, move your graph over, please. Okay, any questions on this? You don't need to turn this in. This is now done we did it together. I shouldn't have to check it because I just showed you how to do everything. I want you to keep it open though as you work on the lab because I am not going to do the lab with you. You're going to have to do the lab yourself, but I want to show you what you're going to do in the lab before I turn you loose to actually do it. So could you all please come back into your Google Classroom and go under classwork or your assignment list, and you'll see that lab number 2 has been pushed out to you. It's called Graphing with Google Sheets. I would like you to go ahead and open up that Google Sheet that says Lab Graphing with Google Sheets. And you'll see that on this Google Sheet document, the workbook, there are 5 tabs. 1, 2, 3, 4, 5 tabs that you need to do. Let me explain what you're going to do on each tab. On tab 1, 2, 3, and 4, you are making the graph only that goes with the data table. So let me write this down. What do you need to do for each tab? So tabs numbers 1 through number 4, what you're going to do is make the graph using the correct technique that we learned the other day. And then I want you to add, make sure you add the equation to each graph. Okay, you're going to add the equation to each graph. Then, once you've done that, you're going to go to the Analysis tab. And if we look at the Analysis tab, you'll see that it's telling you to answer the following questions. Let me make this a little bigger. Answer the following questions for each of your graphs. And it tells you that your answers are going to go in the shaded cells. They're going to go in the shaded cells. These are the questions you're going to answer. Question 1 for each graph is what's the shape? Question 2 for each graph is what's the relationship? Question 3, you will only answer if the graph is a straight line. If it's not, you're going to put NA. Just like we did with the example, right? On that graph, Google Sheets graphing practice we just did, you put NA if this question does not apply. If it's a line, I want you to tell me what the slope of that graph was with the units, just like we did on our practice. If it was a line, I also want you to tell me what was the y-intercept with the units. I don't need you to rewrite the equation for it, though. So basically, we're doing what we just practiced, but not writing the equation for the line. Okay, Elise? Yes. No, you're not typing it in. Yeah, just have, so you know how we selected that option to use the equation for the label? I want you to add that. So instead of going back at the end and adding it, add it as you make your graph. Okay? Everybody cool with that? You should remember how to make your graphs. You should remember what the trend line options are. If you don't, remember that you have the examples we just did together to look back at to help you. All right? And that is due before tomorrow's class begins. So you have the rest of our double period today to work on getting that lab done. And if you finish early, then you can start working on the review assignment to get us ready for our first test next week. Okay? Sound good? All right, I'm going to let you work. If you get stuck, let me know. Okay, so undo. Let's use your undo button. Keep going. Hmm. It's really weird. All right, let me see if I can add it back in for you. All of tab 4.
Yeah.
Give me a minute. I have to look at your lab in particular. Can you close your file out for a minute though while I edit it?
Like exit out.
Yep. It's there. It's showing that it's there. Close out your, it's tab 4, right?
Yeah.
Number 4, go ahead, check it. Because I see it. I'm looking at your actual assignment and it shows it. There it is. Okay.
Thank you.
You're welcome.